Here we are going to establish relationship between coefficients of the polynomials and zeros of the polynomials. I mean the relationship between the coefficients an minus 1, etc., a1, a0, and the zeros alpha 1, alpha 2, etc., alpha n, since a polynomial of degree n has n zeros, and therefore we are going to establish the relations between ai's and alpha i's here. Now first let me consider the relations between the linear polynomial. Before that, I would like to give one hint here, or a point to be remembered are noted. If alpha 1, alpha 2, etc., alpha n are the zeros of the polynomial px an x raised to n plus an minus 1 x raised to n minus 1 plus so on and so forth, plus a1x plus a0 is the polynomial of degree n. I mean the leading coefficient an is not equal to 0. Then px can be factored into n linear factors as px is equal to an into x minus alpha 1 into x minus alpha 2, etc., x minus alpha n. This can be seen through the the factor theorem and fundamental theorem of algebra. Now first I am going to consider the a linear polynomial. A linear polynomial, general form of the linear polynomial is px is equal to ax minus plus beta. If alpha is a 0, you can see here, if alpha is a 0 of px, then px can be written as a into x minus alpha. Now you can see here that can be written as ax minus a alpha. This can be written as ax plus of minus a alpha. Now compare this coefficients, particularly the constant term. Therefore, b is equal to minus a alpha, and that can be written as alpha equal to minus b by a. And this in terms of words I can write down, this is minus constant term divided by coefficient of x. And with this help of this one, if you know the zero of the polynomial, you can find out the a linear polynomial. For example, if alpha equal to minus 3 by 2, then we can write down px is equal to x minus 2 into x minus alpha. Alpha is here minus of minus 3 by 2, which can be written as 2 into x plus 3 by 2, and which gives us 2x plus 3. So given 0, we can find the polynomial, and now we can consider a quadratic polynomial uh, now px is equal to ax square plus bx plus c. And now as earlier in the earlier case, you can see here, if alpha and beta are the, if alpha and beta are zeros of px, then px can be written as a into x minus alpha into x minus beta. After multiplying these two linear factors, you can get a into x square minus alpha x minus beta x plus alpha into beta, which can be written as ax square minus a into alpha plus beta into x plus a into alpha beta. Comparing these coefficients of x square and x and constant term, therefore comparing the coefficients, so we get the coefficient of minus a into alpha plus beta is equal to b, and a into alpha into beta is equal to c. Therefore, what you can get, alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. And this I can write down sum of zeros, alpha plus beta is equal to minus coefficient of x divided by coefficient of x square, and alpha into beta is equal to coefficient of, or I can write down this coefficient of, coefficient of, constant term, constant term divided by coefficient of what is that, x square. This I can write down this as a minus 1 raised to 2 into coefficient of constant term divided by coefficient of x square. And how this will help us to find out the roots as well as what you can say, polynomial itself. For example, here consider if alpha sum of zeros is equal to minus 3 by 2, minus 3 by 2, and the product minus 2 by 1, 1 by 2, minus 3 by 2, and product is minus 1, and therefore we can write down px is equal to, if alpha and beta are the roots, x minus alpha into x minus beta, and this is equal to x square minus alpha plus beta into x minus 1, and this can be written as x square minus alpha plus beta is equal to minus 3 by 2, 3 by 2 minus of minus, that is going to be plus 3 by 2, minus 3 by 2, minus 3 by 2, minus 3 by 2 into x minus 1, and this is going to be x square plus 3 by 2 x minus 1 minus 1, and this is going to be, if we are going to equate it to 0, because alpha and beta are the zeros of this polynomial, therefore px is equal to 2x square plus 3x minus 2. This is the answer which you can see through the verification. Now I am going to consider the cubic polynomials whose coefficients and their zeros can be, relations can be established here. The cubic polynomial, here the cubic polynomial px is equal to ax cube plus bx square plus cx plus d. As usual, as in the case of quadratic polynomial, I am going to consider px if alpha, beta, gamma are zeros of px, then px can be written as px is equal to a into x minus alpha and x minus beta into x minus gamma, and this can be, first I would like to multiply these two linear polynomial as a into x square minus alpha plus beta into x plus alpha into beta, and then I would like to take out this x minus gamma to be multiplied with this quadratic polynomial, and therefore, and this is equal to, I can write down a x cube minus alpha plus beta into x square plus alpha into beta into x, then multiply minus alpha to each term of the quadratic polynomial, so I can write down minus gamma x square plus gamma into alpha plus beta into x minus alpha beta gamma, and therefore px, simplifying this one by taking x square terms, adding x square terms, and then adding the coefficients of the xth term, and therefore px equal to, I can write down, simplifying this one, a into x cube minus a into alpha plus beta plus gamma into x square plus a into, and these are going to be the zeros take product, sum of the product taken 2 at a time, alpha into gamma plus beta into gamma into x, plus I would like to write down minus a into alpha, beta, gamma. Compare the coefficients of px in a standard form, that is comparing with the px, that is here ax cube, comparing the coefficients. And of x square, x and constant term. We get minus a into alpha plus beta plus gamma is equal to b, and a into alpha beta plus alpha gamma plus beta gamma is equal to c, and minus a alpha beta gamma is equal to d, and therefore this comparison will give us alpha plus beta plus gamma equal to minus b by a from this. And what is exactly this is? Minus coefficient of x square divided by coefficient of x cube, and alpha into beta plus alpha into gamma plus beta into gamma is equal to what is that? From this c by a, c by a is equal to that is the coefficient of x divided by coefficient of x square, and also alpha beta gamma is equal to d by a is equal to constant term divided by coefficient of x square. In this fashion, coefficient of x cube, here x cube, and in this fashion we can establish a relation between coefficients of a polynomial px is equal to ax cube plus bx square plus cx plus d. And now I can say in general, if the polynomial is of degree n of the form px is equal to standard form an x raised to n plus an minus 1 x raised to n minus 1 plus etc. plus a1x plus a naught, and if by the fundamental theorem of algebra, if alpha 1, alpha 2, etc., alpha n are the zeros of this polynomial, then it can be as usual in the case of quadratic polynomial and cubic polynomial. This can be written as px is equal to a into x minus alpha 1, x minus alpha 2, so on and so forth, x minus alpha n. By the similar expansion which we have done in the case of quadratic and cubic polynomial, this can also be done in this same fashion, and proof I'm going to leave it as an exercise, and therefore we can have this in general, the relation which you have written here. You can go through the proof in the next level.